Welcome to Pre-Calculus, Section 5.3 on Other Functions with Radicals. When we're solving equations with radicals in them, we have to be aware that extraneous solutions can occur, and we want to be checking for those along the way. Even if you do all of your algebra steps correctly, you can end up having extraneous solutions. So raising both sides of an equation to an even power can cause an extraneous solution. This is because of the square root of a number has two values, or the fourth root of a number can have the plus or minus versions, etc. So you want to plug your solutions back into the original equation to check for extraneous solutions. That way we can eliminate any that don't cause your original equation to give you a true statement. So in this example, we're going to solve this equation. So we want to isolate the radical first, so I would divide by -7. And that will give me the square root of x plus 7 is equal to 8. And then I would square both sides. And I'll get x plus 7 is equal to 64, when x is equal to 64 minus 7, which is 57. So to speed things up, I wrote out the check step already. So I'm going to take my 57, I'm going to plug it back into my original equation. I'm going to simplify that all the way down, and I'm going to get that -56 is equal to -56, which is a true statement. So I'm going to say that x is equal to 57 is the solution to this equation. Let's solve this equation. So this is the fifth root of 5x minus 8, which is equal to 3. So I want to get rid of that fifth root. So I'm going to raise both sides to the fifth power. So I'll get 5x minus 8 is equal to 3 raised to the fifth power. So that's 3 times 3 times 3 times 3 times 3, which is equal to 243. So I have 5x minus 8 is equal to 243. So I add 8 to both sides. 5x is equal to 251. So dividing by 5, x is equal to 251 over 5. All right, so this is a fifth root. It's an odd root. So we shouldn't have any extraneous solutions. This should work. But you can go ahead and check it to prove to yourself that you didn't make any mathematical errors along the way. So I carried through the check step, and I did get 3 is equal to 3, which is a true statement. So we're going to say that x is equal to 251 over 5 is the solution to this equation. So you want to go ahead and perform the check step just to ensure that you didn't make any errors along the way, even if it is an odd root that we're dealing with. Okay, now we have an equation with 7th roots in it. So we're going to go ahead and raise both sides to the 7th power to lift off those 7th roots. So I'm going to get 3x minus 2 is equal to x. So bringing the x's all to one side, I'll get 2x. Bring the -2 over to the other side. 2x is equal to 2. Divide by 2, and I'll get x is equal to 1. All right, now we want to perform the check step. So I went through and performed the check step. 1 is equal to 1. So we're going to conclude that your solution is x is equal to 1. Okay, now we're solving a square root equation. So let me rewrite it. So you want to isolate the square root first step. So we'll get 2 square root x plus 8 is equal to 4. So I'm still working on isolating the square root. So I've got it isolated now. Now I want to square both sides. and I'll get x plus 8 is equal to 4. So that means x must be equal to negative 4. Now I'm going to perform my check step. So I substituted negative 4 in for x, and I simplified all the way down. I got 10 is equal to 10, so that's a true statement. So my solution is x is equal to negative 4. So on my next example is I've got a square root on both sides of the equation. So I want to square both sides of the equation, being careful that I surround everything, that 5 as well, within my squaring brackets, parentheses. So I'm squaring both sides. So 5 squared is 25. Squaring the root 3x plus 2 will give me 3x plus 2. And on the right-hand side, 2x plus 24. So I've got 75x plus 50 equals 2x plus 24. So subtract the 2x over here to the left. That's 73. Subtract the 50 over to here. I'm going to get 73x is equal to negative 26. So I need to divide by 73. I'll have x is equal to negative 26 over 73. All right, so now I want to check this. So I went ahead and I plugged my fraction, my solution that I believe, into my original equation, and I simplified it using a calculator. So I took my decimal places out to 4 places so I can be pretty accurate here. So my last statement is a true statement out to 4 decimal places, so I believe this is a true solution. Check. So my solution is, I conclude this is a true solution. So my solution is negative 26 over 73. Make sure you do your check step on these. So I'm going to solve this equation. I've got a variable on either side. So I want to lift off the radical first thing. So I'm going to square both sides. So I get negative 8 plus 6x is equal to x squared. So this isn't a linear solution. This is a quadratic solution because of that square. So I want to get all of my terms moved to one side. I'm going to strive to have a positive x squared in case I'm going to factor this. It'll be easier that way. Okay, so I'm going to solve this quadratic. First I want to check to see if I can factor it. If not, I'll use quadratic formula. So 1 times 8 is 8. So I got 1 and 8, 2 and 4. Multiply to give a positive 8, add to give a negative 6, so I need 2 negatives. All right, so that is factorable. So I'm going to say my factored form is x minus 2, x minus 4. And I'm just going to remind you again, because I still see some of this going on, the only time when you're factoring a quadratic where you can actually take these two numbers and put them directly in the factors is when you have a 1 here. Okay, if you don't have a 1 right here, if you have a 2, 3, 4, whatever you've got there, you're going to have to factor by parts. All right, so this is my factored form. So my solutions now are x is equal to 2 and x is equal to 4. All right, those are what I believe are my solutions. Now I want to perform the check step. So I first checked x is equal to 2, substituting back into my original equation in 2 places, 2 here and 2 here, simplifying, simplifying, and finally my last statement is a true statement. So I'm going to conclude that x is equal to 2 is a true solution. And then I check the 4. So I substitute 4 here and here, where I have x's in my original equation. I simplify, simplify, simplify. I get a true statement at the end. So I conclude that x is equal to 4 is also a solution to this equation. So you must perform these check statements. If I give you one of these on a quiz, I'm also looking for that check statement to make sure that you're able to show that these aren't extraneous solutions. Okay, so we've got x minus 2 is equal to the square root of 7x minus 24. So I need to lift off the radical by squaring both sides. So on the left I have x minus 2 squared, which is x minus 2 times x minus 2. On the right I have 7x minus 24. So this is x squared minus 2x plus 4. This is 7x minus 24. X squared minus 4x plus 4 is equal to 7x minus 24. Okay, so I've got a quadratic again. I'm left with a squared term. So I want to get all the terms onto one side and have a positive coefficient of my x squared term. So I'm going to subtract 7x and add 24 over to the other side. So I'll have a 0 here on the right. So I'll have x squared minus 11x plus 28 is equal to 0. Right, now I want to see if I can factor that, or else I'm going to use the quadratic formula. So I have 1 times 28. I want to find the two numbers that may work. So there's 4 and 7 as well. All right, so 7, 8, 9, 10, 11. This is going to work. Two negatives. Negative 4 times negative 7 is 28. Negative 4 plus negative 7 is negative 11. So since I have a leading coefficient of 1, I can say my factored form is x minus 4. X minus 7 is equal to 0. Since I have factors, I have solutions. Opposite sign, x is equal to 4, x is equal to 7. All right, now I want to check these. So I'm checking 4 first. I'm substituting 4 back into my original equation wherever I have an x, and I'm carrying through, simplifying down, and I get 2 is equal to 2. So I conclude that 4 is a solution to my equation. Same with 7. I'm substituting 7 in where I have x in my original equation. I'm simplifying down. I get a true statement. 5 is equal to 5. So x is equal to 7. So I have 2 solutions to my original equation. Okay, on this example here, example 8, I've got radicals on both sides. And I have 2 terms here. So when I square it, it's going to become a more complicated equation to solve. So I'm going to square both sides here. So I've got 3x plus 4 is equal to 2 plus square root of 3x minus 3 squared. So I'm going to write this out twice. All right, and now I'm going to continue on simplifying this. I'm going to distribute. So let's write out our distributing operation carefully here so we don't mess anything up. So I recommend doing this when you're distributing something that has more complicated terms in it. All right, so I took 2 and I distributed to this binomial here. I took this radical term and I distributed it to same thing here. So now I'm going to simplify that. So that's 4 plus 2 times the square root of 3x minus 3 plus another 2 times the square root of 3x minus 3. I'm putting the 2 out in front here. And then the last one would be this times this. Notice that it's the same underneath on both of these. So that causes you to be able to take off the radical here. So this is just going to be the inside of that radical, 3x minus 3. All right, so let's condense things a little bit here. So I've got 2 of these plus another 2 of these. That's 4 of those radical terms. All right, so now let's see what we can simplify here. So I have some like terms on either side, which I'm going to go ahead and cross off. Those will subtract out. These will subtract out. So on the left-hand side here, I've got 0 is equal to 4 times the square root of 3x minus 3, and then I've got minus 3 here on this side here. So I've got 4 square root of 3x minus 3 is equal to 3. As I'm isolating my radical. So I've got the square root of 3x minus 3 is equal to 3/4. All right, so now I want to square both sides to lift off the radical. So I have 3x minus 3 is equal to 3 squared over 4 squared. All right, now I want to add 3 to that. So I'll get 3x is equal to 9/16 plus 3. We need a common denominator here. So that's 3x is equal to 9/16 plus 48/16. So that's equal to 57/16. All right, so now I want to divide by 3. All right, that's the same thing as multiplying by 1/3. So I have x is equal to 57 on the top, 3 times 16 on the bottom. So that's 57 times 1. 16 times 3, that's 48. So I think my answer is 57 over 48. So now I'm going to perform my check step. So I use my calculator to check this. So I plugged in 57 over 48, and I took the square root of this number underneath here, and I got 2.75. And then I used my calculator to figure out this number, and underneath took the square root of that. I added 2 to that, and I also got 2.75. So I get a true statement when I plug back in my original, my solution. So I'm going to go back over here, and I'm going to say this is the solution to my original equation. Okay, so here we go again. So I'm going to rewrite this. Now it looks like I need to get this radical out of here, so I'm going to square both sides. So here's square both sides. So that takes off my radical. And on the right-hand side, I've got x minus 3 times x minus 3. So let's just carry this out. So I've got x squared minus 3x, so that's minus 6x plus 9. So I want to get all my terms onto one side and strive to get a positive leading coefficient on the quadratic, because it looks like I have a quadratic here. So that means I want to add 2x to both sides and subtract 30 from both sides. So I'll have x squared minus 4x minus 21 is equal to 0. So now I want to see if I can factor this. So I have 1 times negative 21. So that's 3 and 7. All right, so I need to multiply to give a negative, which means I need one negative. I need to add to give negative 4. So I'm going to apply the negative right there. So this will work. So I'm going to factor this. Since I have a leading coefficient of 1, I can create the factors straightforward. Put these numbers right in the factors. All right, since I have factors, I know solutions. Opposite sign. So now we have to check. All right, so I'm going to take -3 and plug it back into my original equation in 2 places. Simplify down, and I end up with the square root of 36, which is 6, equal to -6, which is a false statement. So I've got an extraneous solution for x is equal to -3. So then I go ahead and I plug in my 7, and I check that one as well, and I get a true statement. When I simplify, 4 is equal to 4. So I'm going to conclude that x is equal to 7 is the solution, and x is equal to -3 is extraneous. Okay, so here's one more example, and then we'll be done. So I'm going to square both sides here. So I'll get x plus 6 is equal to x plus 4 times x plus 4. So that's x plus 6 is equal to x squared plus 4x plus 4x. So that's 8x plus 16. All right, so I've got a quadratic to solve here. So I'm going to get everything over to one side. So I'll have 0. So I have x squared plus 7x plus 10 equals 0. So I'm going to check to see if I can factor this. So I have 1 times 10. And I have to multiply to give positive 10 and add to give positive 7. So I can factor this. Leading coefficient of 1. So I can place these numbers in the factors directly. So if you have factors, you know solutions, opposite sign. So now I need to test these 2 solutions out. So I went ahead and I plugged x is equal to -2 into my original equation where I have x, and I simplified it down, and I find that 2 is equal to 2, which is a true statement. So x is equal to -2 is a true solution. Then I take x is equal to -5, and I substitute that into my original equation, and I simplify, and I get a false statement. 1 is equal to -1. So I conclude that x is equal to -5 as an extraneous solution. So I have one solution to this equation. Okay, so that wraps it up. So this section is about solving equations with roots. Go ahead and attempt your homework set now, and remember to send me a picture of your problem if you have a question.